Recording in progress.
Hey everybody, it's March 23rd. Class is starting a little bit late. This is computer science, intro to programming. We're working in C++. Last class we went over structures and their methods. And today I thought we'd do a little project. The project we are going to do, I guess I could put it at the top because I'm telling all the students to do it. I'll put my name in. We are going to design a triangle object using structure. And what's today? 3/23. And
not 2002.
Go ahead.
It's definitely not 2002.
You're right. Learn to type, David. This David, not you.
I have the same problem, so it could be said either way.
Right? So remember, for our variables, we use lowercase to start with, but for objects and stuff like that, we are going to use a capital letter. And so I thought, projects you don't start coding. So I thought we should maybe work out some ideas of how we're going to do this.
Can I ask a question real quick?
I got my trusty program or notepad up over here, OneNote.
So on your comment using lowercase for variables and uppercase for objects, is that actually programmatically a rule, or is it just best practices?
It's best practices. It will still work if I do lowercase.
Okay.
It makes it when everyone uses the custom. It just makes it easier.
Makes everybody's life better.
Just like when we do ax squared plus bx plus c, we do descending order. That's not law. I mean, this works just as well. But anybody that knows math is going to think less highly of you and think maybe you don't know what the fuck you're doing if you have that.
Roger.
So, that's a great question now. So let's think about a triangle. What could we do with the triangle? Like, what variables could we use? I mean, let's see. Let's draw a triangle. We're going. Oh, that's a shitty final line. Oh well, good enough. So a triangle. We got a point here. We got a point here. We got a point here. We got angles. We could call this angle A, angle B, angle C. You know what? I'm going to call this D just because the lowercase looks different. And then the opposite side is the lowercase. So I'm going to do A, B, and D. So, we don't want to just do right triangles because that would be pretty easy. Like a right triangle, we know everything. Base, height, areas, 1/2 base times height. We can do some easy trig to get these angle values. That's your good old SOHCAHTOA, but that's not every triangle, so I mean, not really what we're looking for. So I'm gonna get rid of that. And so let's look at the options we have here. If we do angles, we don't want to record them all because then that's just too much. We're storing too much data. The object is to store what you need such that everything else can be calculated. And the reason why is calculations are cheaper than storage. Calculations, your RAM uses it, it calculates real quick, and then it opens it right back up. Storage, it's got to keep it in memory for the life of the program, so if you don't really need it for something, don't store it. So, we could do angles if I had 3 angles. So let's look at our options here. Angles. I could, we know they add up to 180. Why is my pen marker so wide there? There we go. Add to 180. There we go. That looks a little better. Angles add to 180. So maybe if we did like, I don't want to do 60, 60, 60. Let's do 60, 70, and then 50. If I had those three angles, I would have a triangle. It would be, it's not quite 60, 60. So one of the angles is like that. Maybe that's the 50, 60, and the 70, which is good. That would give us a triangle. Is there any downfalls with that? Is there any downfalls to using angles? Well, turns out there is. This triangle has the same angles. So similar triangles have the same angles. So that's not really unique. So we did, that one's definitely not good. We don't have unique triangles. Oh, part of that's off the screen. That's why. There we go. What about sides? Yeah, we got a good old 3, 4, 5 triangle. We could store the three sides. Is there any downfalls to that? You think of anything? Because like with this, we could calculate all the angles, right? We could do some trig.
Mm-hmm.
The only real problem with this is I could say enter side A, B, and C. And they could do some shit like 10, 5, and 30. Which sounds good. Like if you don't know enough about triangles, why not? But if I draw a triangle that has a length of 30 and then a length of 10, and I try to do another 5 to connect it, I can get degenerate triangles. Degenerate. I love that word. That is such a great word. So, like, we could do data validation. There's a way around this. We could do data validation. Data validation for this would be the triangle inequality. And just so you know, any two sides, when you add them together, should be greater than the third side. I said D up above, so I'll put D here. Or any combination of that. Maybe side 1 plus side 2 is greater than side 3. And that works for every circumstance here other than having side 1 and side 2, one of these being side 1 or side 2. If side 3 is 30, this doesn't work. We don't have a greater than situation. So we could data validate that. So that's an option. So let's keep that on the table as something we might use. And let's consider finally points. Good old, let's just leave it in 2D, not 3D. Our Cartesian coordinate system. I could say, 1, 1 here. 2, 5 up there. And I don't know. Oh, I could make it. Oh, we'll do it way over here. 6, -2, something like that. With those, we could make the lines. It makes a triangle, right? So can we find the lengths of the sides?
Yes.
How?
I
You
forget
are
what the name of
correct.
the formula is.
It's called the distance formula.
Distance formula. Thank you.
So we can do the sides. That's it. That's a check mark. Can we find the angles?
Yep.
Yes. Starting with three sides, the easiest one to start with is law of cosines.
Is there a reason that the distance formula is really any different than Pythagorean? I mean, it's a squared
Pythagorean,
plus b squared equals c squared, right?
correct.
And you're
Because you're
just
still
basically,
finding the side, but the Pythagorean theorem is locked to right triangles.
but isn't, I mean, that's what you're
It's the
doing is you're
same. It's
building
the
right
same thing.
triangles to get the distances, right?
Yeah, yeah. It's still the same formula. Yeah.
Yeah, okay.
So distance is x minus x1. Or I got 2 points, so x2 minus x1 squared plus y2 minus y1 squared. That's the side length. Angles, we could do law of cosines, and then once we've got one angle, you could do law of sines. But for programming, why would I do more than one code? So I can get all the angles. Uh, is there any downside to this? They could choose to enter the same point. They could put in like 1 1, 1 1. In fact, they could do all of them 1 1. But let's say they did one of them as 2 1. You got double point in one spot, and then you just got a line. And then the triple one, you just got a point. These are still in the degenerate triangles. So we got to choose between sides or points. Which one like keeps more information for us? Which one is better?
I would say sides. And then
Argue it for me.
on your third side, you can use your first two sides to place bounds on your third side.
Well, we could also place bounds with points. You cannot make the same point.
That's true.
And both of them, like if we want to, and that would be again be the data validation.
So then
And you are
then using
correct.
sides would just be using sides would be less calculations that you would have to do
You're right. There's less math
internally.
up here, right? And there's definitely more math down here. You need the Cartesian system, or you need to do law of cosines and stuff like that. But really, once you code it up, it's not that bad. Does it? This one's got more work. Is there any? Does one of them offer more information?
Technically, points offers more information.
Points does offer more information, right? Can we get the points from the sides?
No.
No, we can't. So let's go with points. So I could do this. I could go. We could do. No, we're not gonna do integer. We're gonna do double. I could do double x1 y1, and then I could do x2 y2, and I could do x3 y3. And that seems like a lot of variables right now. I could do arrays. I could do like I'm making an array of 2. Maybe call it P1.1, size 2, P2 size 2. These are options. And both of those mean I gotta store all that crap in and I gotta work with arrays every time. Let me come up with a third option. If we're gonna make a structure for triangles, why don't we make a structure for points? And we'll just keep in this X and Y. And I totally used T. There we go. I was being lazy and didn't want to retype it. And then I could just come over here and we'll get rid of that. And I'm going to go point P1, P2, P3. Those seem like good names. P1, P2, P3. And okay, so we got to start. What kind of things should we include for a triangle?
Sides.
So we already mentioned that, and that's good. We should find the
Height.
sides or calculate sides. So I'm gonna put this in here as a little to-do thing. Methods to calculate size.
Height.
Calculate sides. What else?
Height.
We can do height. Height's
Area.
kind of rough if you don't know which side's the base, though. Do we want to go with height? Why would we want height?
Height is going to be used in area.
If you do the 1/2 base times area, you already did
true.
that Heron's formula, though. We already got the code for.
That's true.
Oh, I wanted to have that text writing up over there. We already got the code for Heron's formula, so we could still use that. There we go. This will give me a little bit more room to type. So we don't really need the height. That's extra. I mean, I'll leave it in there as something we can calculate. We may want it. Anything else we might want?
Area. Perimeter.
Area is a good. Perimeter is a good one. In fact, we probably need perimeter for area if we're doing that Heron's formula. So you should probably have one for displaying out the shit that we got, right? So, like for sides, let's do the display first. That's easiest. It doesn't need to take anything. Void display. Try. And we'll prototype it here. And make some room so it's easy to do down here. But I don't know what we're seeing out right now. Maybe we'll see out the points for now. I guess if we're going to see out the points, we could make a display function for a point, right? That way, let's do a display function up here. I'm going to separate that a little bit because we've got our variables here and we've got our methods here. And I did void display point. I'll come down here and do that down here. It already, since it's a method, it automatically has access to it. All the variables. So I could just tell it to see out. Maybe I'll make it look like a coordinate system. So we'll put that in there. And then I'll add in X. Oops. And then I'll say, maybe I'll put a space in there and say comma space. Put in the Y and close it off. And it's telling me I got something wrong, and I do. What do I got wrong? Oh, you weren't here for the methods. You had left at that point. We need to
Mhm.
we need to scope it out. When we use methods instead of functions, we got to do the scope resolution. So we put the name of the object followed by 2 colons. And I got to do that down here as
Okay.
well. And that'll scope out the problem. And that cleaned that up, made it work just fine. Let's come up here and test it. Oh, you know what? Let's do one that gives us a 3, 4, 5 triangle where we know everything. 3, comma 0 and
Mm.
0, comma 4. And the origin. And I think I typed something wrong there. I did. I put a colon. And now I could have the display for the triangle just, I could do display point. And what did I call my points in here? I called them P1. Maybe I shouldn't call them P1 here. Well, oh well, too late. No, I think it's confusing.
L1.
Say that again.
L1.
L?
Good. Location. Loci.
Ooh, I don't like that. Let's go capital L. Fuck it. I'm breaking the rules. I'm being a rebel here. I'm using capital variables.
L is in loci.
I like it. Let's do it. And since point is part of structure, I can use the access the point methods here. I could just say display point. But I need to choose a point. So I'll go L1 and then I use my dot operator and I get access to my stuff. So we'll do display point and it takes in a void. And then we'll do the same thing with L2. We'll do the same thing with L3. And let's just make sure this works. Oh.
So your triangle method there is referencing your point method, and your point method is saying to see out
The points.
that value.
Yeah.
Points.
So I need to make a triangle. My try. I like it. Triangle, my try. And it takes in, since I've already made them, P1, P2, P3. I need an equal sign in there. And now I can do my try and I can do display. Display try. All right, let's see if this works. All right, we got our points in. Points are good. Let's take a look at the next thing. Let's cross them off as we do them. We did the display. Display's done. I think we kind of need the sides next, right? So let's expand on this right here using the points I've got. I've got P1, P2, P3. So, and I should be able to access them. Where am I? Let's come down to the main. Like I can do P1 dot X. So that would access my X coordinate. So if I wanted to make the function, I could do like P1 dot X minus P2 dot X. And then I got to square it. Plus P1 dot Y minus P2 dot Y. And I got to square it. Since I'm squaring, maybe I'll shift to POW. Shift to POW. So I'll go POW, comma 2 plus POW, comma 2. And what side does that give me here? Let me draw my triangle again. I want to see my triangle. So 1, 2, 3, A, B, D, little a, little b, little d. So P1 minus P2 is getting me side D. Maybe I shouldn't have used D because D is for distance. Oh well, that's how my pictures have been done. So I could do that. Let's just make sure that works. Double D. Oh, this is getting even worse. I definitely shouldn't have used D. Did I include C math up above? I did. I got C math. We will do.
So when do you decide what to put in the main and what to make a function out of?
Well, right now I'm just putting it in the main to test it. I'm probably going to make a function out of it. But
that's what I'm saying is like what makes you decide that? Like what criterion, or is it just like whatever you want to do, but try and make an organized
to make the
kind of
main
thing?
look less cluttered as possible. That's what I would go for. This actually isn't even done. Then we need to do the square root. So I guess I got to kind of do square root first, right? Square root all that. Like you can have everything in the main. It just looks terrible. Right? We don't need functions or anything. Let's see, square root, and then, okay, I'm going to do my, I'm just filling them in with blanks for now. And now, let's see, the X part was POW. I need to do P1 dot X minus P2 dot X. And then I do that. Let's make sure my parentheses are all looking good. Nope, I did not need that one. There we go. And now I can do the same thing with Y. So I'll copy this over here and put Y.
Why?
It needs to be a plus right here. I said X minus Y. I don't know why. I do P1 dot Y minus P2 dot Y. So this is X1 minus X2 squared plus Y1 minus Y2 squared. And we'll see out D. Let's just see if that worked. 5. I got it. So that gave me the side length. I need to make one for A and B though also, don't I?
Mm-hmm.
Side A and side B. So this is definitely telling me I should make a function. This is where I don't want to do the code more than once. Why don't I make a function or a method in the triangle where it returns the side? So return side. Maybe we just input what side we're looking for. So like double, we'll call it calc side. And why don't we call them sides 1, 2, and 3? Nope. A, B, and you know what? I'm done with D. Let's go with C. I've given up on D. So we got to take in a char. And I'll copy that. Do that. And I'm going to come down here. That's got some extra space. And I need my function up here. Copy that, put that in here. Let's just call this double temp. And I don't know what we're returning yet. So let me comment it out. We've input the size, so maybe we should do it to do some if statements. If R equals A. What is A on my picture? A would be 0.3 and 0.2.
2 and 3.
So we'll do temp equals. And I'm just going to copy that up there and put that right there. And we will change that to be 3 and 2. And the convenient thing when you're squaring it doesn't matter what order you put it in. And I have to scope it. It's getting pissed. I keep forgetting to scope it. Oh, it's not P3, it's L3. And then we can do else if R equals, too many equals there, B.
Is there a reason you're not using a switch here?
Nope, switch works just fine. Switch is probably better.
Well, I'm just sitting here thinking you're either going to have to nest ifs, or I feel like a switch is cleaner there.
Oh, switch arg. Case. Shit, yeah, I gotta put that.
Mm-hmm.
Yeah, I gotta put the quote marks. That's much cleaner. I like that. Look at that. Look at that. I don't even need the equal sign. Look at that. Beautiful. I love it. Less writing. And I gotta change B is points 1 and 3. And we'll do case. I liked what you did with having him in a row like that, rather than writing it twice. I think that was good design. Let's see.
Thanks.
I think it was you that did this, right?
Yeah, I did it with my yes/nos.
I think that looks good. And C is my D, so that was 1 and 2. So it doesn't really matter which one I copy. I need to do breaks in there, don't I?
Mm-hmm.
I knew something was missing. So we do break. We do break. And we do break. And default. I'm just going to say temp equals -1. We know that can't work. And now what do we say? Return temp.
Mm-hmm.
Why are you lining it up right there? What's missing here? Why does it not like it?
Are you supposed to be using brackets at the beginning of the switch? I can't remember. Switch 3 plus C plus plus. Yeah, you don't have brackets at the beginning of your switch. Right there after arg, you should have a bracket open and then a bracket close after all of it. Or braces, sorry.
Yeah, there we go. You see how often I use switch? I knew something was wrong. I would have just looked it up like you were doing. You were checking your notes, I think.
Yep.
All right, so maybe we should you know what? I'm gonna get rid of this end line right here. I don't like this end line. I'm gonna just put some spaces in that, print the point. Because I think I want display triangle to print the sides too. So C out side A equals calc side. Damn it. And we'll do this with side B and side C. So I'm going to relabel my picture real quick. Not too bad, right? Why do I got an extra one? Is this? Oh, there we go. And since I put it in display triangle, I don't even need to. Maybe I'll do a new line after the points. Maybe I should say something more. Here's the info regarding a triangle with points. And now I don't need that in there. Let's. Oh, delete the wrong way. Looking good? 3, 4, 5. Bam! 3, 4, 5 triangle. Bam. All right. So, let's see. That took out sides. Perimeter's pretty easy. I'm gonna put the display shit at the bottom. That way, whatever I'm working at is at the top. There we go. That makes more sense. So it's returning a double, and I need to scope it to the triangle. And see, when I don't copy and paste, I don't make that mistake. I remember to scope it right away. And I don't have an input. And we're just going to return calc side A plus calc side B. Put a little space in there. I gotta do capital letters, even though I made both cases. It's in my head. It just looks like shit if I don't. I gotta maintain consistency. Is everything looking good there? Yeah, my parentheses are looking good. So that returns the perimeter. So let's add that to our CO. Perimeter is easy, right? That's easy.
Mm-hmm.
3, 4, 5 is 12, yeah. They average to 4, so 4 times 3 is 12. All right, so this is working on that. We'll try it with non-right triangles in bit. There's no reason to think this won't work, though. We got rid of area. No, we didn't do area yet. We got rid of perimeter. Oh, we need angles in there, too. So, what was Heron's formula? Heron's was square root, or S is the semi-perimeter, which is perimeter over 2. And it was the square root of S times S minus A times S minus B times S minus C. Is that about right?
I think so. I got to bounce over to physics now.
Okay. I'll keep recording this and put it up. Have a good day.
Cool. Thanks, man.
Uh-huh. All right. So we're going to take a look at doing the area. And we're going to do the area with Heron's formula. So let's do that. Area is going to be a double. And calc area, maybe. And we already have everything we need, so we'll just come down and make it. Come down and make that right here. Oh, it's awkward not having anybody here, and I'm talking to the wall. All right, we can still do this. Calc area. And it's void. And let's see. I'm going to make a temporary variable for S. Double equals perimeter. And since I'm a method, I don't need to put it in its method of the triangle. I just need to tell it's a method by putting parentheses divided by 2. And I need to say that's S. And so we're going to return. We need the square root. So let me make this kind of big. We start off with S times S minus A times S minus B times S minus C. Okay, that's the actual thing, but I need A. And A is from calc side A. And B is from calc side B. And C is from calc side C. So let me space this out a little bit, make sure everything's looking legit. So S and times S minus calc A. Yes, then times. And then I got my parentheses again. I got an outer parentheses and then the inner parentheses for calc side B. And same thing going on there. Everything looks right. If I do that, I'll tighten it back up. And since we're got a nice display function, see out the area equals calc area. And let's see, a 3, 4, 5 triangle. Let's look at this pictorially. I could do 1/2 base times height is the shortcut one on this. Is 6. I should get an area of 6. I did. And now I'm seeing something that I'm missing here. I think I'm missing units. I think I want my triangle to have units. I really do. So let's add a string. We'll call it units. And let's just, in here, I will add in, what do we want to go, centimeters? We'll go with centimeters. And I want to add that to my cout. So I will calc side here and then put space and then units. And I'll make that my ending for all of those. But on area, it's units squared. So I need to add and one of my students knows how to do this easily. Let's see if there's an easy way of getting that. In C++, how do I make superscript? How do I make superscript 2? Char 253. So I'm going to make that a global constant. Let's add this as a global constant. I'll call it SQ equals char 253. And I should just be able to do SQ afterwards. Let's come down here to the units and let's put that in. Rather than doing this, I'm going to put in SQ. Did that work? Look at that beaut. So that's a good use for using like the internet. Looking up something simple that doesn't affect the program other than make it prettier. That's a great thing to do. Look at that. Beautiful. Beautiful. Although I think I need some more spacing here. I don't like the way that's looking now. So I think I want after my points, I want another new line. And then I think after the sides, I want a new line. That's the wrong slash. Looking good so far. All right, so angles. Angles. I'll just redraw my picture. So the law of cosines says I'm going to use B for now. B squared equals A squared plus C squared. Nope, wrong letters. I need lowercase. What am I doing? Capital letters are for the angles. B squared equals A squared plus C squared. And then you do minus 2 times the letters you got, AC. And then you have cosine of the angle opposite the other side. And this goes with all of them. C squared would be A squared plus B squared minus 2AB cosine C. That's probably the way they normally, that's the standard form they listed in. And then A is B squared plus C squared minus 2BC cosine A. So I don't want to, we want just the angle. We want B, C, and A. Or A, B, and C if I want to say it like an intelligent person. So let's solve this one. Let's solve this one for A. I could subtract B squared and C squared. And then I divide by the coefficients. And I'm left with cosine A equals A squared minus B squared minus C squared. You know what? I'm going to move this negative up here and change the signs. So it'll make it, I don't like having all that negative on the bottom. It looks tacky. B squared plus C squared minus A squared. Kind of like if I added that over there and subtracted the A squared over. And then divided by 2BC. And if I want to get A by itself, I need to do cosine inverse. And in C++, that's A cosine. So I could do A cosine of both sides. And if I do that, I get what I'm looking at. So I got A equals side A cosine I've got, I want to use a different color for these inner parentheses. Divided by 2 times B times C. And since I'm doing, and I know I need to do POW for each of those, since I know that I got to calculate B, C, and A more than once, I'm actually just going to store it. And I think we'll do angle, set up the angle thing the same way we did the calculate side. We're going to do calculate angle. And I'm going to work smarter, not harder. So I'm going to come down here and I'm going to copy this. calc side. I've put it up here near the top. I'm going to shift this to say calc angle. And we just need to change what temp is. I'm going to say 0 for a second. I don't like having all that extra stuff that's distracting me. All right, so I got double temp. You know what? I'm going to make double A equals calc side A. And I'll do that for each of them. And the good thing about doing these, I know we didn't want to store them up above in this structure where they're running the whole time, because when this method stops running, all the memory is deallocated and is available to use again. So even though I'm making variables right now, it's not going to stay in the memory. Now I just need to make it look like that. So temp case A. Case A is what I got over here. I need, let's get rid of that colon at the end. I need A cosine. And then I'm going to do bracket. And I'm going to have pow B comma 2. You know what? Let's just skip the pow. I do need the parentheses though. Let's do B times B plus C times C minus A times A. And that's that parentheses. And then we divide by 2 times B times C. B squared plus C squared minus A squared all over 2 times B times C. All right, so I'm going to copy this down here. What changes? For case B, whatever letter I'm doing A here. That's the one that's negative, and that's not the one that shows up over here. So B is the one I need to be negative here. And I can't have B in the denominator. And we'll do the same thing on this one. Here, C is the one that's got to be negative. And C can't be in the denominator. So it's going to be the A and the B. And that's bothering me because I like my stuff in order. To be honest, this is bothering me too. Ooh. And we'll get rid of that plus. And what does this return? A here is in radians. So if I want to convert from radians to degrees, degrees equals radians times 180 over pi. So I think I'm going to actually call this calc radians. And then I'm going to do one that calc degrees. And it's going to look just like this one. So I'll double that. It's going to be called calc degrees. But here, all I need to do is I don't need any of this. I don't need temporary variables. I need to, this is calc radians right there. I need calc radians arg times 180 divided by pi. And I don't even think the case matters other than for the radians. I think that's all I need. I think I can put that right there. In fact, I don't even mean to make it a variable. I'll just say return. But I don't have pi. I'm gonna make pi a constant up here at top too. Let's make pi a constant. You know what? Maybe I should make SQ capital like pi. I'll change that in a second. On the unit circle, I'm not going to do 3.14. I want it to be accurate. So on the unit circle, let's see, pi radians would be this. So this is -1, 0. So I could do arc cosine at -1. And I redefined SQ, so I need to change that in my printout. And I got my thing here in that. So let's come in here and do this in our printout. I'm gonna call this angle A, go angle B, angle C. And we're not using units, we're gonna type radians here. And this has got to be calc radians. So I'm minimizing my time by copying and pasting my code as much as I can. And then we're going to do the same thing. I'm going to do the same thing. I'm just going to make this degrees. You know what? I think I'm going to do degrees first. And I'll put the angles, the radians afterwards. If you want the radians instead of angles, or instead of degrees, I guess I can just put the end line up here. I think I did too much all at once. I think this is a little hard to, like I should have just tested 1 degree first. What is a 3, 4, 5? What angles am I expecting? I should have a 90. And I got SOHCAHTOA. So sine of, let's see, sine of this would, that angle would be opposite over hypotenuse. And adjacent is adjacent over hypotenuse. That should be the angle symbol, not it. And then tangent shouldn't show up anywhere. But I should see these two things. 4/5 would be 0.8 and this would be 0.6. Hold on, that ain't right. I need sine inverse of that. So what is sine inverse of that? Sine inverse of 0.8 equals 0.92729, and cosine inverse of 0.8 or 0.6. Why am I getting the same thing? Oh, this angle is giving me, I only need that one. That's why. It is the same thing. Then I got to multiply this by 180 over pi. Times 180 divided by pi. I'm getting one of these degrees is 53.13 degrees. The other should be 90 minus that. And what is that? 36.87. I'm doing that in my head, which isn't always the best thing. 36.87. That's rounding to 2 decimal places. Let's see what we get. Three, four, 5. 53.13. Look at that. 36.87. Look at that. Boom. So maybe we should fix the precision. Like I only got 4 decimal places there. I've got 6 here. Let's fix it at 3. So if we want to fix it at 3, we need to include the IO manip. Under 3, I think I said. Let's check it out. There's some extra spacing in there, but hot damn, this is looking good. Look at this bitch. Looking good. Oh, wait. I need that up so I can find out where my extra spaces are. So display after sides, I got an extra space there. I don't know that I need. And I don't know. We'll take that out, see how it looks. You want to be really cool. Now we want to make it look cool. Let's do this. I'm going to use /t after all my equal signs. That should line up the values. I don't know that I want to do it on perimeter yet, an angle yet, so let's just see how that looks. Yeah, I do. It don't look good that way. Looks like area needs another one. Look at that. Isn't that beautiful? I guess I didn't really label side A, B, and C, so they'll have to figure it out from the triangle. They drew it. But here we've kind of saved all the information. We got all the points. Let's kind of review what we did. So we started off going, what do we need? We did the area, we did the angle. I don't know that we need the height. That's a pain in the butt. So what did we need? We looked at sides, angles, points. We went with points. And then we made a display to print those out. And then we decided we needed to calculate the sides. And with the sides, we did the angles. The sides also led to perimeter and calculate area. So clean that up a little bit. We added units to make it look a little bit better. Since we had units squared, we did the square one. So this generates the square symbol, which is a superscript 2. And it replaces typing that. And here is pi without being rounded, using some trig. So we made our points, we picked some points, set it up. The only thing different would be maybe giving the user the opportunity to pick those points. So let's make a temporary x or double xy. Please enter. I need to say what we're doing. This program does all the calculations for a triangle. Requirements are 3 points, x comma y. So let's just see out. Please enter the x value for the first point, for point 1. Point 1 is the side where A is, angle A is. So I'll call that point A. And I'll do the same thing for y. Please enter the y value, C and y. And now I'm going to move this point down here. Point P1. No. P1 equal, because I want all my variables declared up top. P1.x equals x. P1.y equals y. And I will repeat this process for all 3 points. So this does point 1, captures point 1 from the user. And B is 2. So this, I'm documenting it for people reading my code. And this final one would be 0.3 or C. And now we do our create the triangle and do all the calculations via display triangle. Just give it a try, see how it works. So I'm going to use the same points I had. Let's just change the order of them. I'll do the 0, 4 as the first. I'll do 0, 0 as the first point. And then I'll do 3, 0 as the second point. And then I'll do 0, 4 as the fourth point, or third point. Now I'm seeing that I need some spacing in here. So where do I need my spacing? I want my spacing, I want a space right here. And I want a space right here. And I want a space right there. And I want another space here, so I'm going to do end line I'll do a double end line right there. So we're doing 0, 0, 0, 3, and 4, 0. That's my test one. Now we can just do all sorts of stuff. So, I don't know, let's go with negative 3.4 and 20.1. And here we'll do 10.2 and 6.8. And let's see, let's have a negative y value one. Let's go with, well, let's make it crazy large. 30.7 and negative 16.23. Oh, that's a crappy triangle. Really? 176 degrees. Now I gotta look at what I wrote. What did I pick? What was that madness? $10.2, 6.8, and 30.7, negative 16.3. So we'll make this increments of 10 like this. So negative 3.420 is like right up here. We'll change colors. 10.2, 6.8 is right there. And 30.7, negative 16.3 is down. I guess that is. Is it going like that? I made almost as flat of a triangle as possible. That's crazy. Like we got 2.5 degrees and 1.5 degrees. That is so small. You can't even imagine how small that is. That's super small. It works though. So I think that's gonna be a wrap on this project. Since there's no one here left, I will say peace. Take care. Adios. Ciao. I'll post this code up.